Hi, welcome to the Mathemagic channel. Today we look at Arithmetic Sequences 101. So this is part A. We'll have two parts. The second part is dedicated to the sums. In part A, we're looking at finding terms, finding the name of the sequence, and at the end we'll look at matchstick patterns. This is really important, really cool, and really simple if you know how to do it, and I hope this can help you. Let's jump right in. So what is an arithmetic sequence? Well, an arithmetic sequence is a sequence of numbers which progresses with addition, which means that if you go from one term to the next term, you're adding a certain quantity repeatedly. I'll give you an example. Here you have un equals 5, 8, 11, 14. And so to go from 5 to 8, we added 3. And to go from 8 to 11, we added 3. And to go from 11 to 14, we added 3. So I think that's pretty important here is to locate the first term. Well, the first term is 5, and what we call the common difference, the difference between two terms, is 3. So one of the first skills you need to learn when you do arithmetic sequences is to think about how we find the common difference. And so if you look at un equals 5, 8, 11, 14, you naturally see that 3 is the common difference because you're thinking, well, how do I get from 5 to 8? I added 3. How do I get from 8 to 11? I added 3. Now, mathematically, the word difference means subtraction. So if it wasn't as obvious as 5, 8, 11, 14, you would have to do something like a subtraction. So you would do 8 minus 5, or 11 minus 8, or 14 minus 11, and realize that all these differences, which is why it's called a common difference, all these differences are the same. And so if all the differences are the same, then we know that the sequence is arithmetic. And so the way to do that is to do u3 minus u2. So in this case, u3 is 11, u2 is 8. So when you do u3 minus u2, you get 3. When you do u2 minus u1, so 8 minus 5, you get 3. So 8 minus 5 is the same as 11 minus 8, and this is 3, which is D, the common difference. So let's look at some sequences here with a difference of 3. 5, 8, 11, 14. We've seen this one already. 6, 9, 12, 15. This also has a common difference of 3. 100, 103, 106, 109. These all have a common difference, which is 3. So there's not just one sequence which has a common difference of 3. There are many sequences which can have a common difference of 3. So all of these have a common difference of 3. And in order to identify them, we're going to have to give them a name, but the name of each sequence might be a little bit different since they're not the same sequence at all. So the first thing to notice is that if a sequence is moving in threes, we're going to call it a 3n sequence. 3n is really important. If you look at 3n in essence, like un equals 3n, and we replace each value of n by a number starting from 1, the first term in the sequence, u1, will be 3 times 1, which is 3. The second term in the sequence will be u2, which is 3 times 2, which is 6. And the third term will be 3 times 3, which is 9. 3, 6, 9, 12, 15, 18. This looks a lot like the 3's times tables. That's because it is. So a 3n sequence is essentially the 3's times tables. So if we look at un equals 3n plus 1, remembering that 3n was the 3's times tables, we just kind of added 1 to every value here. So u1 would be 3 times 1 plus 1, which is actually 3 plus 1, which is 4. And u2 will be 3 times 2 plus 1. So remembering that the value of n gets multiplied by 3, it's 3 times n, and then we add 1. So it's actually 6 plus 1, which is 7. And then u3 is 3 times 3 plus 1, which is 10. So the sequence un equal 3n plus 1 is the sequence 4, 7, 10, 13. So it's exactly the same as the 3's times tables, but we've kind of scooted it across by 1. And so every 3n sequence is a version of the 3's times tables adjusted for the starting point. So this sequence here is 4, 7, 10. And it's called 3n plus 1. So if this is making sense to you, let's look at 3n plus 100. Well, this would be like the 3's times tables as well, moved across by 100. So instead of being 3, 6, 9, 12, it'll be 3 plus 100, which is 103, and then 6 plus 100, which is 106, and so on and so forth. So if we calculate it, we can do 3 times 1 plus 100, which is 103, 3 times 2 plus 100, which is 106, 3 times 3 plus 100, which is 109. And as you see, instead of going 3, 6, 9, 12, it goes 103, 106, 109, 112. So this is another sequence, which is also a 3n sequence, but it starts at 103. So what's the idea in general? You could just find the common difference of a sequence, and then you could look for the starting point and then realize that it's a version of some kind of times tables. So in this case, because we're looking at 3n's, it's a version of the 3's times tables. If you're looking at 5n's, it would be a version of the 5's times tables. And then you kind of adjust the starting point so that instead of starting on the first number of your times tables, so if it's 3n, instead of starting at 3 and you wanted to move across to 4, you would need to add 1 to it. If you wanted to start at 5, you would need to add 2 to it. And then you could write your formula for the sequence. So we could try one here. Imagine that we have our first sequence for today, which is 5, 8, 11, 14. This sequence moves in 3's, so it's a 3n sequence. But it starts at 5. So how much do we need to adjust the 3 so that it starts at 5? Well, we need to move it across by 2. Instead of starting at 3, it's going to start at 5, right? So we need to scooch it across by 2. So the common distance is 3. That's found easily either by logic or doing 8 minus 5, 11 minus 8, the next term minus the previous term. And so it's going to be like a 3n plus something sequence. It's a kind of a 3n sequence. And we know 3n is the 3's times tables, and if you scooch it across by 2, you get 5, 8, 11, 14. So the next point to think about is the formula that's usually given at school. So is there a formula for these kind of sequences? And actually there is. And so here's the formula that's given to you at school, which is un equals u1 plus n minus 1d. And I've had many students look at this formula and be like, what is this and why do we need it? The difference with using logic and using a formula is that logic can get you to the answer right away, and a formula is something that you can use when things get a little bit complicated and your logic kind of can't make sense of it. So it is good to have a formula. Now realize that this formula is the first term plus a number of distances, and it's like n minus 1 distances. And it gives you un. Un is any term. So how does this work? Let's look at this formula a little bit in more detail. So if un was 5, 8, 11, 14. Now we already know that this is a 3n plus 2 sequence. We've already done this. The first term is 5. So we can say that this is 5 plus n minus 1 times the distance, which is 3. So it's the first term plus n minus 1 times the distance, and the distance is 3. If we expand the bracket, we can do 3 times n and 3 times negative 1. So this is using bracket expansions. So un equals 5 plus 3n minus 3. 5 is a number, 3n is a variable, negative 3 is a number, so I can put the 5 with the negative 3 together, which gives me a 2. So my sequence un is 2 plus 3n. And if we write it just like we did before, it is actually 3n plus 2. So 3n plus 2 is the sequence 5, 8, 11, 14. And you can find it with logic, thinking I've got jumps of 3 and I'm adjusting for plus 2 to get to 5. Or you can use this formula, which is I've got a first term of 5 plus n minus 1 times the distance, which is 3. And of course, in both cases, you find the same formula because there's only one, expression for un. Un is 3n plus 2. It's a sequence of 3's that starts 2 to the right. So whether you want to use the formula or whether you want to use logic, this is entirely up to you. So should you be using formula or logic? You pick. It's really your decision. So let's talk about this formula a little bit because it looks a bit tricky. It's actually not too bad. If you think about it logically, between the first term and the second term, you have one distance. Between the first term and the third term, you have two distances. So between the first 10 terms, if you're to think about U1 until U10, well, you would have 9 distances. So this is a little bit difficult to wrap your head around. But between n terms, we have n minus 1 distances. Remember, the formula has this bit with the n minus 1 inside. So the formula is un equals u1 plus n minus 1 distances. There's one less distance than the number of terms. So if you had 100 terms, you've got 99 distances. You've always got one less distance than the number of terms. So to illustrate this for you a little bit, here's some fencing. And you'll notice that we have pickets, right? So imagine the pickets are like the terms in the sequence. So you have u1, and then you have u2, and then you have u3, and u4, and u5, and u6, and we have 7 terms here, or actually 7 pickets. In between those 7 pickets, we have 6 distances. We have the distance from the first to the second to the third, and the third to the fourth, and so on. So we have one less distance than the number of terms. So the distances are like the mesh in between the 2 pickets. And oh, here's a moo cow. Bye. So using our formulas, we can find specific terms in a sequence. So if un is 5, 8, 11, 14, well, we can express it as 3n plus 2. So I hope you feel comfortable with this now. If un is 5, 8, 11, 14, it's a 3n sequence, and whether you want to use the formula or whether you want to use logic, you should now be able to express it as 3n plus 2. Now, what if the question was asking you to find the 10th term in the sequence? Well, that wouldn't be too hard. You just use your formula. So u10, the 10th term, is equal to 3 times 10 plus 2. And so 3 times 10 plus 2 is 30 plus 2, which is 32. So this sequence, which goes 5, 8, 11, 14, if we wanted to find the 10th value, it'll be 32. Let's try now for Vn equals 103, 106, 109, 112. This is again a 3n sequence, but it's 3n plus 100. So if we wanted to find the 10th term, we would do 3 times 10 plus 100. So we're going to do that. 3 times 10 is 30. 30 plus 100 is 130. And so again, we can find the 10th term, we can find the 100th term, we can find the 1000th term without having to keep counting, which is a big save in terms of your time, right? You could also find specific terms with the picket fence. So this is kind of like if you were to use the formula, logically speaking. So again, imagine you have 5, 8, 11, 14, and you wanted to find the 10th term. Well, the 10th term is the first term plus how many distances? So if I want to go from the first term to the 10th, I have 10 terms. I must have 9 distances. So I'm going to do 5 plus 9 distances, and each distance is 3. And 5 plus 9 times 3 is 5 plus 27. And so U10 is 32. So again, starting from 5, if I want to get to U10, I need to count 9 distances, because between U1 and U10, there are one less distance than number of terms. And this is really, really important. So you can say it's 5 plus 9 times the distance, which is 3, and 5 plus 27, which is 32. So this is pretty cool. So if you had 103, 106, 109, 112, okay, so the first term is 103, the distance is 3, so that's the same as before, u1 plus n minus 1 distances. Say that I wanted to find the 10th term, I could start with 103 and add 9 distances to it. Now 9 times 3 is 27, 103 and 27 gets me to 130. So we're able to use this formula to find any term that we want, or we can simply use the formula that we had earlier, which was 3n plus 100. So 3 times 10 plus 100 would also get you to 130. So how about if a question's asking you to find which value of n, or which term has a certain value? So I'll be a little bit more specific. for the same sequence, 5, 8, 11, 14, which term is equal to 32? Well, what you do is you use mathematics to save yourself, and so you say that the 3n plus 2 sequence is equal to 32. So 32 is equal to a certain value of n, 3 times a certain value of n that we don't know, plus 2. And now we use algebra to solve it. So the plus 2 is going to move to the left, so plus becomes minus. So 32 minus 2 is equal to 3n, which means 30 is equal to 3n. And if you move the 3 to the other side, times becomes divide. And so 30 divided by 3 is 10. And so 10 is the value of n. So for the value 10, we will have a term which is 32. So when n reaches 10, we will have 32. So this is kind of like a reversey question. Like I give you the output, I give you the value 32 and ask you for which term this is going to be true, right? So 32 happens when n is equal to 10. And all you need to do is put the formula 3n plus 2 and make it equal to 32 and solve for n. We can do another one here. So for u, n equals 103, 106, 109, 112. So which term is equal to 130? Well, we're going to need the formula. The formula is, it's a 3n sequence and it starts at 103, so it's going to be 3n plus 100. So 130 equals 3n plus 100. The plus 100 moves to the left. 130 minus 100 is 3n. So 30 is equal to 3n, and then times becomes divide. 30 divided by 3 is n, which means that for n equal 10, we will reach the value 130. So you can do these kind of reverse questions as well when you're looking to find terms in a sequence. And all you need to do is to make the formula equal to the value you're looking for and solve for n. So I also often have students coming to me with pattern problems, and this is in like lower grades, right? So this matchstick pattern, I've seen this question a bunch of times. It's pretty important to know how to solve it, but also to get an understanding of sequences when you see a question like this. So if we investigate this a little bit, we'll realize that in the first pattern we have 3 matches, and then in the second pattern we've added 2, so now we have 5 matches. And then in the third pattern, if you ignore the shape that we already had, we added the corner 2, which means we now have 7. And then in the fourth pattern, we most likely have 9 matches. So this sequence is a sequence that moves in 2s, so it's a 2n sequence. And if you followed what we did in the first part of the video, you'll realize that we need to add 1 to it, because this almost looks like the 2's times tables, but it's scooted across by 1. So instead of being 2, 4, 6, 8, it's 3, 5, 7, 9. So we can say it's a 2n sequence with 1 added to it. So this is the 2n plus 1 sequence. And so if you wanted to find the value of the 2n plus 1 sequence at 130, you do 2 times 130, which is 260, and then add 1 to it. So the value for 130 is 261. So the 130th pattern will have 261 matchsticks. Not too hard, right? Let's look at another one of these. So in this one we have a first pattern which, if we count, has 4 matches with the square, right? And then 2 matches up top, so 4 plus 2 is going to be 6. And then we're adding 3 matches on the side and 2 matches up top, so we've added 5 in the second pattern, so that's 11. And then we're doing the same thing in the third shape, so you can imagine that this is going to be 16, and if you keep adding 5, then this is going to be 21, 26. So this is a 5n sequence. And instead of starting at 5, it starts at 6. So you guessed it, this is 5n plus 1. This is what we write down, 5n plus 1. And so if you wanted to find the 150th value, you do 5 times 150, which is 5 times 15 is 75, so 750, and you add 1 to it. So this is going to be 751. And this is how you can do a question like this. Realize that it moves in 5, so it's a 5n sequence, and you scoot it across by 1, so that it's the 5n plus 1 sequence, starting at 6, moving in 5s. So we hope that this video was useful to you. Remember, patterns are everywhere around us, even on your grandma's wallpaper. If you like this video, make sure you like and subscribe to the Mathemagic channel. We will also add a worksheet in the description below so that you're able to practice finding patterns, naming patterns, recognizing which term is in the sequence. Thank you so much for watching today, and we'll see you on the next one. Bye-bye.